after learning point-slope form, the next form of a line that'll be important to our studies is called slope-intercept form. We're actually going to derive slope-intercept form from what we learned previously, point-slope form. But before we do, we need to cover a couple of definitions. The point where a line crosses the x-axis is called the x-intercept. And the point where the line crosses the y-axis is called the y-intercept. If a line has y-intercept 0b and slope m, then the point-slope form, what we learned in the previous video, of the line is then given by y minus b equals m times x minus 0. Remember, point-slope form was y minus y1 equals m times x minus x1. So if we treat 0b, the y-intercept, as x1, y1, then we can plug ordered pair 0b into x1, y1, and that gives us this equation right here. Solving this equation for y leads to the next important form of a line. Definition: given the slope m and the y-intercept 0b, the slope-intercept form for the equation of the line is given by y equals mx plus b. So back up here, if we calculate what's inside parentheses here, notice that just gives us x. So we end up with y minus b equals m times x. Then, if we add b to both sides, we end up with y equals mx plus b. So again, this is what we call the slope-intercept form. If we want to write that in function notation, we can simply replace the y with f of x, and we have f of x equals mx plus b. So let's apply this slope-intercept form on example 4. Write the equation of the line with slope 5 and y-intercept 0, negative 2 in slope-intercept form. Again, slope-intercept form is y equals mx plus b. So from the given information, we can see that our slope m is 5 and our y-intercept here is 0b. So b is negative 2. So we can plug that information into our form. Y is going to stay a y. I'm going to replace the m with 5. I'm going to keep the variable x, and we're going to replace b with negative 2. And we have the slope-intercept form of a line. That's simple enough. Let's try example 5. Write the equation of the line that passes through the point 3, 4 with slope negative 1 in slope-intercept form. So the information that we have at our fingertips here is a point that the line contains and the slope of the line. If you listen to that, we have enough information to write the point-slope form. So we're going to begin with what we learned previously, y minus y1 equals m times x minus x1. And we can recognize 3, 4 is x1, y1, and our slope m is negative 1. Once we have that taken care of, then we'll translate this to the new form, which we're calling slope-intercept form. So let's plug in our information. y1 is 4, m is negative 1, and x1 is 3. So there's our point-slope form. Now we're going to translate this to slope-intercept form. As a reminder, slope-intercept form is y equals mx plus b. So to get from our point-slope form to slope-intercept form, we just need to isolate y. We want to get y by itself. So I'm going to first distribute our negative 1 to break up the parentheses over here on the right side. This is going to give us y minus 4 equals negative x plus 3. And then we'll add 4 to both sides. So we end up with y isolated, negative x, and adding 4 to this side gives us a plus 7. So that is our slope-intercept form. So our starting point was the point-slope form. And by isolating y, we ended up in slope-intercept form. Slope-intercept form is also useful when you need to graph a line. Let's take a look at example 6. Graph the given lines using the slope and y-intercept. So we have the equation y equals negative 3x plus 2. This is y equals mx plus b. So what we can observe just by looking at the form of the line is that our slope m, whatever the coefficient of x is, gives us our slope. Our slope is negative 3. But remember, slope is the ratio of rise to run. So oftentimes it's easier to think about the slope as a fraction. So I'm just going to take this number and put it over 1. So we can see that our rise is negative 3 and our run is 1. Now because our rise is negative, we're going to go down and then to the right. Let's also observe our b value. Our y-intercept in the form 0b, in this case, is 0, 2. So to graph this line, I'm going to start at the point we know that's on the line, the y-intercept 0, 2. And then we're going to use the slope as a map to get to the next point. Remember, our slope is negative 3 over 1. So from the given point, I'm going to go down 3 units and right 1 unit. So we have gone down 3 and right 1. So this next location is 1, negative 1. If I want to generate another point on that line, I can again follow the slope formula, down 3 and right 1. That would be the point 2, negative 4. Now, 2 points are sufficient to determine the line, but you can use the slope to plot as many points as you want. And for good measure, let's label the equation of the line negative 3x plus 2. So once again, as a reminder, if your slope is negative, we're going to go down and right from the y-intercept. If your slope is positive, on the other hand, we'll go up and right. Let's take a look at the next example. We have the line f of x equals 3/4 x minus 4. Remember, f of x is the same thing as y, so we have the pattern mx plus b. So we can see the coefficient of x is the m. So our slope in this case will be 3/4. It's already written as a fraction, so that's good. And in the place of b, we have not 4 here, but negative 4. So our y-intercept is going to be ordered pair 0b, or we can say 0, negative 4. That's where we're going to begin our graph. So I'm going to plot my y-intercept at 0, negative 4, and then we'll count rise over run to the next point. Because slope is positive, we're going to go up and to the right. So we're going to rise 3, and we're going to run 4. And because that rise is positive, once again, we're going to go up. So from the y-intercept, we count up 3 and right 4. And here we'll land at the point 4, negative 1. Again, 2 points is sufficient to determine a line. So I'm going to connect those 2 points with a straight line. Make sure you put arrows on the end of your line to indicate that it does extend beyond just the grid that we can see here. And let's label the line. F of x equals 3/4 x minus 4. So that's the second form of the line, slope-intercept form. We've got one more form to study, general form, in the next video.